In this video, we will learn about the deadweight loss in monopoly. The question is, assuming a downward sloping linear demand curve and a constant marginal cost of production, prove that the deadweight loss due to monopoly pricing as against the marginal cost pricing is equal to half of monopoly profit. Okay, so let's assume we have this inverse demand function, that is P is equal to A minus BQ. This is a linear demand function. Okay, and if I draw it on the graph, what will happen? So when Q is equal to 0, P will be equal to, in this equation, if I write Q is equal to 0, P will be A. So here we will have the price intercept as A, and obviously this is downward sloping demand curve, and let's draw it like this. This is our demand curve. Okay, inverse demand curve. Now what the question tells us? So we have a linear demand curve and a constant marginal cost, and let's also assume we have a marginal cost which is equal to C. This is our constant marginal cost. Okay, then what happens? We have to prove that the deadweight loss due to monopoly pricing. Okay, so the wording is important. We have to find out the monopoly pricing as against the marginal cost pricing. So we have to find out the two pricings here, that is the monopoly price and the marginal cost pricing. By marginal cost pricing, what we mean? So marginal cost pricing means the perfect competitive price. Okay, so first thing is we need to find out these two prices or corresponding output. Okay, so we have two situations. First, let us take the case of monopoly pricing. Okay, what happens in monopoly? What happens in the monopoly for profit maximization? We equate the marginal revenue with the marginal cost. Okay, so we are being given the demand function is this. So first we need to find out the total revenue. Total revenue is equal to price into output, which will be P is equal to A minus BQ. To this we multiply by Q. This will give us the total revenue as AQ minus BQ square. Okay, and what is the marginal revenue? As we know, it is simply the derivative of the total revenue function with respect to output. That is the change in the total revenue due to the change in the output. So derivative of Q is 1, so we are left with A, and derivative of Q square in the second term is twice, so we will get 2BQ. Okay, this is our marginal revenue. Okay, this is our marginal revenue. Now as we know that profit maximization requires, so profit maximization in case of monopoly requires we equate the marginal revenue with the marginal cost. Okay, so if this is our marginal revenue, and let's draw it here. So marginal revenue, you can see the intercept of the marginal revenue function and inverse demand function is same, which is A here, but the slope of the marginal revenue function is twice that of the inverse demand function. That is, the slope of the marginal revenue function is twice the slope of the average revenue function, because inverse demand function is our what we call this average revenue function. And let's draw the marginal revenue here like this. This is our marginal revenue function here. Okay, same intercept, but the slope is twice that of the average revenue function. Okay, now what happens? What is marginal cost? Marginal cost is constant, which is C. And let's draw the marginal cost line also here. So let us assume, let us say this is our marginal cost pricing. Marginal cost, which is C equal. So here we have C as the intercept. So for profit maximization, we equate the marginal revenue with marginal cost. Marginal revenue is A minus BQ. A, now so let us use another color. So A minus BQ, A minus BQ should be equal to the marginal cost, which is equal to C. Let us solve this for Q. That means transposing BQ, it will become BQ, positive BQ will be equal to A minus C. Dividing both sides by B, so we will get Q is equal to A minus C upon B. Okay, but it is here, okay, it is here twice b. Okay, I was getting confused, so it is here twice b, so we will have 2 times b. This is the monopoly output. Okay, and if I draw it on the graph, so profit maximization requires we equate the marginal revenue with marginal cost. Okay, so let us say this is the monopoly output, where q is equal to a minus c upon twice b. Okay, this is the output produced in case of the monopoly. And we can also find out if we need the what we call the monopoly price. Okay, so corresponding to this, we plug the value of q is equal to this stuff into the inverse demand function to find out the monopoly pricing. Okay, so plug this value into the inverse demand function. That means p will be equal to a minus b times the value of q is this a minus c upon twice b. So p will be equal to, here b and b will get cancelled, so if I simplify it here, it will become a minus c upon 2, so it becomes twice a minus a plus c, so we get a plus c upon 2. Okay, had I done it correctly or not, let me see it again. So we get here twice a, then minus a, minus into minus is plus c. Okay, I hope I did it correctly. So monopoly price will be equal to a plus c upon 2. Okay, that is the price in case of monopoly. Now in case of perfect competition, so this is our monopoly pricing. We need to find out the marginal cost pricing, that is the price in case of perfect competition. Perfect competition. I don't know whether the spelling is correct or not. Now what happens in case of perfect competition? What is the profit maximizing condition? Profit maximizing condition is that we equate the price with the marginal cost. Okay, what the question tells us, the marginal cost pricing. Okay, so in case of perfect competition, we equate price with the marginal cost to find out the profit maximizing output and price. Okay, now in this case, since p is equal to c, okay, so we have p and marginal cost is c, so price will be equal to c, and what will be the output then? Okay, so we plug p is equal to c in this inverse demand function, which is same for both monopoly and perfect competition. So in place of p we have c is equal to a minus bq. Let us solve it for, okay, here let me show it here. So what was the price here? A plus c upon 2. Okay, this is a plus c upon 2 is the monopoly price. And what is the perfect competitive price? That is c here. Okay, now we need to find out the output produced in case of the perfect competition. So solving for q, this equation, so we get bq is equal to, okay, a minus c, or q will be equal to a minus c upon b. Okay, this is the output produced in case of perfect competition. So this is our average revenue function when it intersects the marginal cost function, that is p is equal to mc. This point is our point where a minus c upon b units of output is being produced. Okay, let us do it here. This is our marginal revenue function. Okay, so what the question tells us. So first we were supposed to find out the monopoly price and perfectly competitive price and corresponding outputs. Okay, the question tells us prove that the deadweight loss due to monopoly pricing as against the marginal cost pricing is equal to the half of the monopoly profit. Okay, so first we should know what exactly is meant by the deadweight loss. So deadweight loss is actually the cost to the society created by the market inefficiency. And what is the market inefficiency? It is a situation where the supply and demand are out of equilibrium. Okay, so ideally, if we don't have, if I draw output and price here, so we have, if we have this inward downward sloping demand function, and let us say this is our supply function. Okay, so the point where demand and supply functions intersect with each other, this is the efficient output. Okay, so we don't have any inefficiency when supply and demand demand and supply functions intersect with each other. The point where they each intersect with each other is the efficient output, or what we call the socially optimal output produced. Okay, now in this case our socially optimal output will be when this is the demand function and this is the supply function. Okay, so this point is our socially optimal output. But what happens in case of monopoly? We are not equating demand and supply functions to find out the socially optimal output. In case of monopoly, deadweight loss occurs. Why? Because you can see here we equate the marginal revenue function with the marginal cost function. Okay, this point. Okay, this cannot be the socially optimal output because we are producing less at a higher price compared to the output produced in case of the perfect competition, which is more and at less price. Okay, so very simple, deadweight loss is the cost to the society created by the market inefficiencies which occurs when supply and demand are out of equilibrium. Okay, so this is supply function. Marginal cost in perfect competition is actually the supply function. So when supply and demand functions are at equilibrium, we have socially optimal output, and when they are out of equilibrium, and here you can see in case of monopoly, this is our marginal revenue and this is marginal cost. So we don't equate supply and demand. So this point is, or this output is socially inefficient output. How do I put it? So in case of monopoly, deadweight loss occurs. And what is the magnitude of deadweight loss in this case? The deadweight loss is actually, so this is our socially optimal output and this is our monopoly output. So the deadweight loss is this very triangle formed by these 2 pointers. Okay, so this is our deadweight loss. So we need to find out the deadweight loss. So to find out the deadweight loss first, okay, let us first find out the deadweight loss. Then we will find out the monopoly profit and equate it with that very stuff. So deadweight loss will be equal to, we need to find out the area of this very right angular triangle. Okay, so very simple, which is equal to 1/2 of, if we have right angle triangle, its area as we know is equal to base into height. Okay, so what is base? Base is a minus c upon 2b, and here we have a minus c upon b. This is the length of the base. And what is the height of this? Height is this. Okay, this is the height. This is the height and this is its base. Okay, using this very stuff, so what will be the deadweight loss? That is the area of this very right triangle, which will be equal to, we subtract this from that, So we have a minus c upon b, and we subtract from it, this is a minus c upon 2b times height. What is height? Height is here a plus c upon 2 minus c. If you are wondering, let us say this is 10 units produced, and this point is the 10 units of output produced, and this is the 15 units output produced. So what is the length here? This is 15 minus 10, which is 5 is the base. Okay, here we have these parameters, so don't get confused. Same as if price is here 60, here it is 50, so the distance is 10 here. Okay, so don't get confused by these very parameters here. Okay, let's solve this. शायद like very solve करना. Okay, I will solve it here, then I will rub it. So we have 1/2 of, let's make the denominator same. So we have a minus c upon b, and then we have minus a minus c upon twice b. Okay, to make the denominator same, so let us multiply the first term by 2 and to the numerator and denominator, obviously. Okay, then we have this very, let us do the calculation. We have a plus c minus twice c divided by 2, which will be equal to 1/2 of, so we will get here twice a minus twice c divided by twice b minus a minus c. So this is here, this minus twice b. Okay, let us try to solve this. So we have 1/2, we have the same denominator, we can add at the denominator or subtract. So we have twice a minus twice c, then we have minus a, minus 1 into minus is plus c divided by twice b. Okay, times we have this very stuff, minus 2c plus c is minus c. Okay, so we get here a minus c upon 2. Okay, so we have 2a minus a is 1a, minus 2c plus c is, okay, let me write it here now. So dead weight loss will be equal to, we have 1/2, then we have 2a minus a is a, minus 2c plus 2c is minus c divided by twice b times a minus c upon 2. So what will be then dead weight loss? Dead weight loss is equal to, so we have 2 to the 4 to the 8, let's take the 8 common. Then we have a minus c times a minus c, it is a minus c whole square divided by b. Okay, this is the dead weight loss created due to the monopoly. Now we also need to find out the monopoly profit. Okay, what will be the monopoly profit? So we know profit is equal to total revenue minus total cost. So profit will be equal to total revenue is price and output minus what will be the cost, that will be equal to marginal cost times output, equilibrium output. Okay, very simple. Marginal cost is being given. To find out the total cost, so marginal cost is equal to c, so total cost will be the integral of the marginal cost function with respect to output, which will be equal to c dq, sorry, okay, c times dq. Since c is a constant, let's take it out, so we are left with dq, which is equal to c times the integral of dq will be equal to, simple thing, it is it is equal to Q plus the constant of integration K. Okay, let's assume the fixed cost is equal to 0. So we assume the constant of integration is equal to 0. That gives us the total cost equal to CQ. Okay, so CQ is our total cost, which I wrote here, C times Q. C is the marginal cost, Q is the output. So then the profit in case of monopoly will be equal to, what is P? P we calculated somewhere in case of monopoly, which is equal to A plus C upon 2. And what is output? In case of monopoly, we calculated it as A minus C upon twice B. To this we subtract C times Q. And what is Q? Q is again wait a minute, let's take Q common and let's then solve this to make the things more simpler. So P will be equal to, let's take Q common, we are left with P minus C. Okay, then profit will be equal to, so Q is A minus C upon twice B times, what is P? P is this A plus C, A plus C upon 2 minus C. Okay, so profit in case of monopoly is A minus C upon twice B times, so we have A plus C minus 2C divided by 2, which is equal to, we have A minus C upon 2B. So again we will get A, 1 minus 2 is minus 1, so we will get so we have A minus C upon 2. Okay, I hope I am doing it correctly. So profit will be equal to, let me see if I am in my limits. I am here. So A minus C times A minus C is A minus C whole square. Then we have 2 into 2, which is equal to 4 divided by B. Okay, now this is the monopoly profit, and here you can see profit is actually equal to, so this is the profit, this is the deadweight loss. We have to prove the deadweight loss is half of the monopoly profit. Okay, so how do I put it here? So profit will be equal to okay, so how it is, deadweight loss is 1 upon 8 and monopoly profit is 1 upon 4. Okay, can we write it like this? Deadweight loss is actually equal to 1/2 of the monopoly profit, which is equal to 1 upon 4 times A minus C square upon B. Okay, so deadweight loss is actually 1/2 of the monopoly profit, because the monopoly profit is this very term. Here I have written it like this, and deadweight loss is equal to 1/2 of the monopoly profit. Okay, if you again solve this, so we will get deadweight loss, 2 4s are 8. We will again get deadweight loss equal to 1/8 times this very stuff. Okay, so can I write it like this? Deadweight loss is equal to 1/2 of the monopoly profit. Let us denote it by P superscript M. Okay, don't get confused. Deadweight loss is 1/8 and monopoly profit is 1/4. That means deadweight loss is 1/2 of the monopoly profit. Okay, I hope I have interpreted it correctly. Okay, if there are any mistakes in this videos, please give me the feedback. I'm just doing it by my own. That's how did I comprehend this question. Okay, if you are liking these videos, please share, subscribe with your friends. That's the only motivation for me to keep going on. I am doing this, you know, for free. I don't charge any penny from you people. So the only motivation for me to make more stuff for you people is if you share this channel and subscribe this channel. Okay, see you in next video.